on and live, so feel free to take it away.
All right. Welcome, everyone. In-house and online. Thank you for joining us for our ProTech talk. We've got a great panel here, and I think we're in for a very challenging hour or so here as we discuss some topics of mutual interest in the industry these days. So let me begin by introducing our panel. I'm Buddy Woodroof. I'm the technical manager for ProTechnics, and I'll start from my far right here. We have Dena Demboski. She is the vice president of operations for UpCurve Energy, which is an operating company primarily that operates in the Permian. She's ex-ConocoPhillips. Actually, UpCurve Energy was formed by a number of ex-ConocoPhillips individuals that grouped together to form UpCurve, her being one of them. She is an A&M grad with a degree in mechanical engineering. Formerly, the whoops are here. I can hear them already. She was formerly a senior drilling and completion engineer with Lynn Energy and, of course, ConocoPhillips. So, Dena, nice to have you with us.
Thanks.
Next up, a very familiar face, Dr. Mukul Sharma. He's a professor of petroleum engineering at the University of Texas at Austin, where he has served for 34 years. 37. I had an old bio. Okay, sorry about that. Well, that helps because I was trying to figure out how in the world you had 450 articles in 34 years. 37 maybe.
Explains it. Huh?
37 maybe. Okay. He's a former head of the Department of Petroleum Engineering there in Austin. His research interests include hydraulic fracturing, oil field water management, formation damage, and improved oil recovery. And for the past, I guess it's 17, I got 14 down here, past 17 years, he has led the hydraulic fracturing consortium at UT that's pretty well known in the industry. So next up to my left is Stephen Drylie. Stephen is the manager of engineering petrophysics at Core Laboratories. He is a Georgia Tech grad with a degree in chemical engineering. Oh, I forgot. You're a Southern Cal grad.
I am.
Originally, so forgot that, passed up on that. Had so many other things I had to narrow down the list, you know, I had to eliminate something. Stephen Drylie is a Georgia Tech grad in chemical engineering. He's worked at Halliburton as a frac engineer, then STEM Lab in Duncan, Oklahoma, and now he works for Core Lab there as the manager of engineering petrophysics. Next up on his left is Colin McGonagill. He is the CEO of McGonagill, Lambert and Bay, or MLB, you know, Major League Baseball group here, sometimes referred to. And they currently manage 3 separate assets for Juniper Capital. He has a mechanical engineering degree from Purdue. He is a 4th generation oil field hand. And as his bio describes, his family settled in the Permian Basin back, what, in the 1800s? So definitely got roots there. Formerly with ConocoPhillips, just about everybody at the table here, I think, has served time with ConocoPhillips. And Q-Star, he's been involved in geothermal power generation, has developed some of the most efficient geothermal power systems yet to be formed, as well as being very active in oil and gas production. So, Colin, nice to have you with us. Next up to the far left is Tanner Wood. Tanner is regional engineering manager for ProTechnics, a division of Core Laboratories, where he's worked for 8.5 years. He's a Trinity University grad with a degree in geology and formerly worked with GoFrac as a district engineer and field engineer. So that's the panel, and we're going to throw some questions at them. And we certainly welcome all of the audience here and online to put some questions in the chat. Is that the way we prefer it for the online? Okay. Okay, well, let's start with our discussion starter questions. Our intent here is to talk about where the frac meets the reservoir. So rock interactions, reservoir interactions that impact the fracturing dynamics. So a lot of the questions are going to be centered around that. And I certainly welcome all the panelists to participate. Don't feel like you have to address every question, but if you're comfortable, just give me a nod and we'll call them. So let's enjoy this and share some ideas. Question number one. What completion diagnostic technologies have proven beneficial in your operations? Okay. Who wants to start? I can't call him Tanner because
You get over my unbiased opinion.
I can't call him Tanner. That's not appropriate.
The operators.
That's what he does. So it needs to be probably one of you two. What completion diagnostic technologies have proven beneficial in your operations?
I think they all, I'll start.
Okay.
I think they all have, for the most part, I wouldn't say that we continually use the same science on every well, right? We've dabbled in a lot of different technologies. We've tried shear frac. We've looked at, at the bit rock diagnostics to help us, at least in our particular area in the Delaware Basin. We're navigating through liniments, and then we're having to do completion work around them. And we actually put an URTeC paper out a few years ago on it, where we skip these liniment features, and we've used some of the diagnostics to look at the rock mechanics, how closely we can get to those liniments without fracking them. Both with data collection. Early on, we drilled 3 wells with pilot holes. We've gotten away from that now. We have a pretty good understanding, and we do a lot of on-site diagnostics while fracking, looking at 5-minute ISIPs, looking at kind of opening well pressures. We'll shut down pumping the pad and look at our shut-in ISIP, like we call them our pre-ISIPs, like prior to pumping the stage, to see. And the trend, like the I guess summary of the paper is like you will see lower ISIPs as you get into these liniments, and you can have early indicators prior to putting sand in the reservoir to not frack them. And we've learned that if you avoid these liniments, you make better wells. Your water oil ratios are much lower, like 2-to-1 compared to 10-to-1 if you frack them. Little to no H2S is seen as well if you avoid them. And so we've used tracers. We've looked at different tracer technologies, some core stuff, but we don't do a lot of core analysis anymore. I said a shear frac. We've looked at at the rock while drilling. I would say probably the one I liked the most was the shear frac. Just with their, they've kind of come out with like a real-time system where they call it like watching the grass grow, and you're seeing your shear fracs that are generated while you're fracking, and you can kind of see what rate changes are doing. And we've gotten away. We were pumping multiple sand ramps in a completion stage, and we've kind of pinned that down more to like a single ramp, which has helped us reduce our fluid that we're pumping. So kind of optimizing our completion diagnostics that way.
Cool. I know you've used a few, so
Yeah, let
tell
me,
us about it.
yeah, we've, I would say in terms of order of importance for us, it would be pressure and temperature, both in the in the well that you're, the active well, and in any passive observation wells around. We just finished a study on that in one of my, I do have an operating company that we drill horizontal wells and frack them, so in East Texas. And so we've been talking to Dick about some of the tracer work that he's going to be doing here in the next couple of months for us. So I would say pressure and temperature monitoring in the active well and any observation wells, that's the most useful and the least expensive. And we use that by far the most often. The tracer work would be number 2. And I would say fiber optics would be number 3, primarily because it's so expensive. And so for a small company, it becomes very difficult to go that and do that on a routine basis.
Got you.
Kind of open up. And I think Dena really spoke a lot to this, but a number of different technologies and kind of looking at, the challenge with diagnostics is always just taking the various available diagnostics, bringing in the ones that are cheap and free, which is, the pressure amounts, shutdowns and things like that. And then combining that in with, all the other knowledge from the company. You mentioned lineaments, but things like that geological understanding, that the petrophysics understanding, and making sure that those learnings are brought into the rest of the team to say, here's what I'm seeing. And often the diagnostics, and I've spent a lot of time looking at this, is, okay, what does this mean? But once you get that conversation going and that conversation gets within that team, it says, okay, all these things combine together. And now we have an answer of why this odd thing is telling me this. It's because otherwise it's just data. So really combining that in with the team is where that value comes in to any kind of diagnostics, whatever it might be.
You're very much involved in geomechanics at the bit, like she was talking about right now.
Yes. And what that adds is it helps with the lineament side, but it gets a lot of that information of what are we seeing along that lateral, and kind of pulling that information that we have from any pilot hole logs or anything like that, and carrying that out. Is that consistent? Does that exist further out? Is there some kind of geological feature that's further away?
Great. Colin, how do you feel about completion diagnostics?
Yeah, so at MLB, we're usually brought into a project when the field has like less than 20 wells. And usually it's either a legacy field, so the data is just almost non-existent, or it could just usually be a crapshoot, but kind of on the pressure to temperature thing. So like our favorite thing to do is actually drill a monitor well, take whole core through the monitor well, and then put the Sage Rider pressure gauges about every 100 feet so that you can actually see the offset pressure in the reservoir. And we've run the Halliburton system tilt meters so that you can have confirmation of that. But like my goal is to actually build a downhole pressure model from the life of the well. So essentially from the moment we start fracking till the well is P&A'd, I want to have real-time pressure data for the life of the well. And with the reservoir pressure gauges, what's nice is if you start doing, different landing zones and that sort of thing, you can actually get your drainage over time. So if you might have downhole pressure on your, call it your lower Wolfcamp A well here, but then you might see that you're actually draining in the third Bone Spring. And you can see that by your your monitor gauges. And so we actually found, like when we were at Q-Star, we did a big thing with Core Lab, and we found that we were fracking, I think all the way through the lower Sprayberry. Like we landed in the lower Wolfcamp A, we fracked through the Dean all the way into lower Sprayberry, and we actually were draining the lower Sprayberry first. And you would never have thought that if you didn't have the data. And so my goal is to always have a pressure model for the well and then a pressure model for the reservoir that is independent of the well water. So it does cost money, but I believe good data is worth every penny. So that's kind of what we implement. And then we tie that back to the whole core if we took it.
Well, Tanner, how about a geological perspective? How do you see the value of core analysis and reservoir fluid analytics in planning completions?
I mean, I certainly think that's a big part of it. We see that quite a bit, anytime we're looking at acreage, looking to step out, looking to do anything, it's a big component of it is knowing your rock, knowing how it changes along the way. Typically we don't see a whole lot of it when you're just moving across you're just kind of moving across in completion mode. Not a lot of core going on. You're just kind of hopping from one well to the next. But again, overall, if you're looking at your completion modeling, your reservoir modeling, it's going to be a big component, especially as people start moving out to other acreage, maybe doing some kind of lower tier type acreage movement.
Well, we've mentioned geomechanical technologies. What's been your experience with these geomechanics at the bit? Have you had much experience with that?
Yeah, we've looked at some of the things in terms of looking at both diagnostics as well as, the areas that we drill are particularly hard to drill because they're overpressured, 300 Fahrenheit plus. So we're so focused on actually getting a lateral drilled. The diagnostics part of it takes sort of a back seat at that point. But you can do some useful things in some instances. If you're not sliding when you're drilling through most of your lateral, rotating through most of your lateral, then I think you can get some. You can get it's very difficult to actually get good diagnostic data, but we typically don't do a whole lot of MWD type stuff. But some companies do, and they've got some value out of it. So I would say our experience at these temperatures, because of the limitations of the tools themselves, is very limited. But I would say that there are operators, shallower, lower temperature, lower pressure, that can get some pretty valuable things out of it.
Well, you mentioned about wells that are difficult to drill. Colin, you've been involved in the geothermal side of things. What's it like drilling through granite and metamorphic rock and all that? Tell us about it.
Yeah, I mean, geothermal, I feel like it's doesn't get the respect it deserves. You know, I think a lot of times people look at oil and gas and they think, oh, they know everything. I think geothermal is kind of a very, like, I don't want to say oddball, but it's one of those things. Like we were out in Nevada and Oregon, that area. And actually, I think the USGS is actually doing a lot of really cool stuff. They're trying to do the dry rock geothermal stuff now, super high temperature. And from a drilling perspective, I mean, it's the upper echelon of MWD technology and trying to make electronics survive in 400, 500 foot or 400, 500 degree, type reservoirs. And it's cool to see, but unfortunately I don't do it anymore. I was like, when I got out of it, I was like, I want to make money, so
What?
I came over here.
Go ahead. No, you want to make money. Tell us more.
No, that's why I'm in oil and gas.
Okay. I got you.
I do think that's interesting to kind of hear, though, is that, you often hear about oil and gas technology kind of applying that outside of the industry, but to hear, do you see a lot of that application of that experience from, apparently you do, from that geothermal, really using that, or is that an opportunity that oil and gas should be pushing more for?
Yeah, I think so. The thing I would say is so one of the things, the concepts I think a lot about is like the dream always in geothermal was to have dry geothermal. So that means like a geothermal reservoir, most of the time, the ones that are economic, it's like a big underground river. You essentially pump upstream, the water heats up as it flows downstream, and then you pick it up and put it through your plant. And it's actually not renewable. Everyone says, oh, it's renewable. It's like it has a temperature gradient and a thermal mass, just like a well has fluid in it. And so you actually drop the temperature in the reservoir over time. And so the dream was always, and those high perm reservoirs are very rare. There's very few places in the world, or in the US anyway, that you can develop those. And so the dream was always to have dry rock geothermal. Well, what would that be? I mean, so you need a massive underground heat exchanger. Well, to me, that looks like a lateral, right? A lateral is a 10,000 foot dry rock heat exchanger, right? So I think one of the things like the industry, oil and gas, needs to kind of think about is, what do we do with all these old P&A laterals? Like, what can we use them for? How do we not just leave them there? And I think there's maybe EOR or some other secondary recovery stuff that could be done. But one of the things I think the industry needs to figure out is, how do we convert those long-term to some sort of geothermal, like dry rock type systems? And the thing is, a lot of the geothermal guys can't do it because they don't have the capital. Whereas for us, it's a liability. So how do we capture the liability and convert it to an asset? And I think, MLB will look at that someday, but right now, we're 20 years from that with where we're at in our asset. So.
Well, speaking of geothermal reservoirs, I want to ask the audience, has anybody here ever fracked a geothermal well? Show of hands. You've been involved? Yes, you were. Ergo, yeah.
Geothermal well, and they were hydraulically stimulating these geothermal wells. So think early shale, drilling vertical wells, understanding frac hydro, understanding where your fluids left proppant is going. So we did some work with our proppant tracers, our gamma emitting tracers, to understand that mechanics of frac propagation. So they can do what Colin mentioned about, creating these long laterals and actually using existing hydraulic fracturing technology in geothermal applications?
Yeah, just last month, or yeah, in April actually, at the Ford site, the DOE is funding. They did 3 fracs. These were single cluster fracs with no proppant. So very simple treatments, but they successfully treated 3 stages in the 16A well at the Ford site. And there's going to be more of that. The 16B well is going to be drilled, which is another lateral 300 feet above, or X 100 feet above the original. And the idea is to connect these two with the fracs that are going to be done in the 16A well. So there'll be quite a bit of work done. We're involved in it through UT and through Shell. We have a joint partnership to do fiber optic work on that well to actually monitor what's going to happen. So the 16B well will be instrumented with fiber optics. And as we frac the 16A well in this granite and at the Ford site, we'll be looking at what happens in diagnostics and so forth. So we get quite a bit of data over the next year.
So what was the bottom hole temperature on those wells?
About 350 or 375 in that range.
That's nothing. I'll brag a little bit here. I was out on a geothermal well in New Mexico that we fracked at 540 degrees. Anybody top that?
Wow.
I know Hess has not done any at that temperature. Come on, anybody? Okay. I'm the winner of that contest. Actually, I don't think we really got to 540 degrees. I think it broke higher up in the reservoir. It's probably more like about 380, I think, if the truth be told.
Yeah.
Which gels don't hold up too well at 540 degrees.
Well, these are all going to be slick water. So
Yeah, almost have to be.
Yeah.
Okay. So we got all these diagnostic technologies we've talked about so far. We got the core, we got the geomechanics, we got the completion diagnostics. So let's take a look at these and let's see how we might want to marry these together in developing our reservoir assessments. So how do you pull all this together, Dena, to assess your reservoir in the Permian Basin?
Well, like I mentioned, we've tried and dabbled in, several different types of technologies, and you kind of pick, what your lessons learned are, what are the key takeaways, and apply that going forward, and then try the next technology and kind of merge that, and you're just building block, like you're building your completion model, you're building your completion practices from those key takeaways, and it's over time.
Well, coming from a completion diagnostic company, specifically Mukul's #2 ranked diagnostic technology, we believe in marrying the diagnostics together. We wholeheartedly believe that the more diagnostic data you have, the better your reservoir assessment is going to be. So we definitely encourage multiple diagnostics, and I think that's going to prepare us to make better reservoir decisions in the future.
Agreed. And a lot of it's planning, right? Like you can go out there and collect all this data, but if you haven't really thought through how you're going to use the data and how you're going to apply it on the next well, you end up with a bunch of data that nobody looks at. So I think a lot of the successes come from the time spent planning those science projects, and maybe there's not a lot of emphasis put on that early on. Like the better job you do of planning and executing that piece prior to actually acquiring it, what you're going to do with it, I think the better data you get and the better results you get.
That's a good point. I think a lot of times completion engineers don't really have a game plan for what are we going to do with this data once we develop it. They just think some magical answer is going to jump off the page, and I think you need to have a game plan. You need to have a completion diagnostic scheme and pick your technologies that fit your scheme. So.
And it's not just completion diagnostics. I think it's reservoir diagnostics as well.
That's true.
Because the single biggest question I get asked is, okay, how much depletion do I have and how far is it going from the well? And can I put an infill well here? That is a reservoir question. And any diagnostics you can do to try to address that is extremely valuable, obviously.
Good point. Go ahead.
I was gonna say you have a question in the back.
Oh,
there.
yes, please. Sure.
Excellent point. We constantly collect data and then we end up with these reams and reams of terabytes of data. And it's really difficult to afterwards put that into a useful format. So what is your guys' favorite softwares to actually tabulate and track your use? I would use FracNet, Peloton, but just softwares you guys use for actually tabulating.
He's probably got one of his own. He owns a software company too.
So that's when you come to a university, like
Oh,
university.
here we
And say, we have all this terabytes of data and we don't know what to do with it. And we don't have the time to mess with it because we've collected all this data. Then you come to the cheap graduate students that we have tied up in the dungeons.
The cheap graduate students? That doesn't sound right.
They're like, we've been tabulating, and they're like, oh, we have data, but it's like 2020 forward. I'm like, well, I want all the information back to 2015.
Yeah.
Like, that would be too expensive. I'm like, let's get a student.
Yeah, no, actually, I'm only half joking because that happens to us all the time.
Yeah.
Because people will come to us and say, we have this huge amount of data, can you make some sense out of this?
Besides that.
Yeah, no, that happens a lot, by the way. And we've done a few projects, for many different operators.
So you're not going to specify any specific software package, which is what
Oh,
she's asking.
specific software. Yeah, so we have developed our own. And so it's called Multifrac, and we use that a lot for doing, it's a compositional reservoir simulator. So it does reservoir problems. It has hydraulic fracturing in it. It has geomechanics in it. It has geochemistry, and it has just about all the capabilities. The only problem is that we are terrible at selling it. So we don't sell it to anybody, and we just use it ourselves. So,
You got to go to him to get it. So-
but you're welcome to use it, by the way. You're welcome to come in and use it. It's not terribly easy to use like some of the other commercial software, but it definitely works, and it is something we used a lot.
Okay, let's jump ahead here. In your opinion, what does this industry most desperately need to improve EURs or long-term well performance? What is our greatest need to push the EUR envelope? What can most impact EURs in long-term performance? How about it, Tanner? Got a suggestion?
Tertiary recovery practices, anything in that EOR front, figuring out how we can take all those gases that were just sitting there flaring at the surface and doing some sort of puff recycling or whatever the case may be. But I think, anything that's boosting those recovery factors for the life of the well, not just at the start of the well, I think that's kind of where we need to take some of the biggest strides, where we have the most room to grow on that front.
Colin, any
Yeah,
suggestions?
so mine is actually not so much a tool as it is a philosophy. And I think the thing the industry needs is we really need to be honest with ourselves of what's working and what's not working. We talk about the data problems and all this stuff. We take a lot of data, but my biggest goal as a CEO is trying to figure out the 99% of the data that means nothing and focusing on 1%, right? And so and that just means that sometimes people have really great ideas that are really dumb, that in the end just don't work, right? And we need to just look at ourselves in the mirror and say, hey, these things don't work. These areas don't work. This geology doesn't work. I get dragged into all sorts of private equity projects, and I'm like, what in the world were they thinking when they got into this area, right? And the smartest thing they could do is just jump ship, but they don't. And because they don't want to get egg on their face or whatever. And we burn up so much capital and so much time, energy, and effort just not being honest with ourselves. So I think that's where, if you have a SOFI-H of 0 and you put the best frac on it, do you think it's going to work? No, it's not going to work. And if you have a really awesome conventional reservoir, do you really need to frac it? No. So we can be honest with ourselves, hey, are these projects working? I think as geologists, as completions people, if we have, sometimes guys get, really hyped on an idea or a project, and they'll spend 20 years, working on it and grinding on it, and it's their baby, and they can't shoot it, right? And one of the things that we say in private equity world is you got to be really good at shooting the puppy. And
Shooting the puppy.
Shooting the puppy. You got to get really, really good at shooting the puppy. And I know that's like really kind of harsh to say,
Yes, it
but
is.
the reality is like we're here to like produce oil and gas effectively. And we have to be honest with ourselves that the US oil and gas industry has done a really bad job of stewarding capital. The reason that we are in the position we are in, and I, because I deal with the finance side a lot, is because of bad decisions that were made. And so I think that once we have that honesty, we have the integrity, like that flows into the EUR thing. Like, hey, you should probably only drill good proven reservoirs. Let's start there. And then when you go drill, like, reservoirs that are like maybe unproven, you should probably spend some time studying it first before you go lease up 100,000 acres. Like just really simple things like that, a lot of people actually just don't do. Like I remember a couple of years ago, like I was a huge Illinois Basin fan, and mainly because I went to Purdue. I wanted to like go drill near Purdue, and EOG had 100,000 acres in the Illinois Basin chasing the New Albany Shale. I went and pulled up the core, and it had like porosity of like 2%, was 100% clay. I was like, what in the world? And they sold it for $1 million. I don't know how much they spent on that, but they probably spent hundreds of millions of dollars looking at it. And I just use that as an example of like, okay, we need to be honest with ourselves with what we're doing and the decisions that we're making, and are the results there? And EUR, like, what does that mean? Estimated. That's the first part, right? I can make any EUR or any well look like any EUR if I just hold it flat, right? Like there's 0% decline on this well, or I can make it look like 0 if I just rip it, And so I think that's where we have to be honest with what the data is telling us and the decisions we're making. Like, are they actually good decisions? Are we holding ourselves accountable to those decisions? Do we have the integrity and the humility to be honest with ourselves with what's working and what's not working? And, so at MLB, that's like what we try to do, is just be really honest with ourselves, even if it's, really brutally honest.
I have a question regarding that.
Yes,
So in
please.
that same note, has private equity started focusing on long-term results again and taking a focus on quarterly reports, which seems to have been all the rage, which is why people took their focus off of long-term production goals and had just made it short-term?
No, absolutely not. They haven't. I mean, that's the problem. That's why I'm here talking about it, right? And so like for us, like I've worked with NCAP, I've worked with Juniper, talked to all the big, private equity groups. The reality is the financial side of this business is really messed up. And we can sit here as engineers and talk and, dream up stuff. But at the end of the day, you gotta figure out a way to convince the money guys to be thinking long-term. And I actually think that the best mindset is usually outside the US. So if you go look at how the Europeans are doing it, if you look at how other countries are doing it, they're not trying to target the biggest IRR, the biggest NPV. They're looking for just stable cash flow. And I actually think that's how US onshore should be focused. We should be trying to target very reliable production, very consistent returns, and very consistent performance. Like we should be actually judged based on how good our predictions were. And we talk about reserves, right? What does that mean? That means that you actually have something in reserve. How much of our reserves are actually accessible immediately? None. Usually we're like full chokes open, ESP at max, gas lift on max. Like the reserves are like always based on like, oh, we'll ramp up rigs, we'll ramp up completions practices or crews. I can tell you right now from a supply chain side, there is absolutely nothing you can do to ramp. So to answer your question, just brutally honestly, no, the financial system's completely jacked. And, that's why we like MLB, we're trying to fix that. Like we've gone out and like courted other investors outside of the normal private equity sphere. And I would say that like capital's finally coming back to the space. Like if you look at this, like the oil at $120 and whatever, like people, we're going to start making money again, but it's because we've been grossly underfunded for years, and private equity has destroyed tons of capital by making really bad decisions. So, and I think that unfortunately, the money side of the business is very greed driven. There's not integrity, humility, accountability is not part of that conversation. So until like that changes, like there won't be a change.
So
You're on both sides of this.
yeah, so I'll make a comment that my last E&P company that I sold in 2013 had 30,000 acres of the Albany Shale, and we never touched it.
Yeah.
With good reason. So,
Yeah.
so I agree with what you're saying. But I'll take exception to your comments about U.S. independence, and I think they've been incredibly successful and have done an incredibly good job of developing a resource. Whether or not this actually translates into something that is fiscally responsible and so forth is a marriage between the financial people in New York and the operators that operate these fields. I can tell you that there's the controlling interests in these companies typically held by financial companies. Our company was founded by BlackRock and Goldman Sachs. And I can tell you in 2013, when I sold my company, Goldman didn't want to sell. And it was only because me and my partner had controlling interest in the company, over 50% of the shares, that we were able to sell. It was a huge mistake if we hadn't sold. So it's driven by the financial interest more than by the operators. The operators know what's happening on the ground, but the financial companies control the destiny of many of these companies. It's not true of all of them. I mean, there's great examples of companies in West Texas. Endeavor is a great example. Hillcorp is a great example of companies that are run by oil and gas people rather than bankers. And so there's a clear distinction between companies run by bankers and companies run by oil and gas people. And I think the companies run by oil and gas people are typically better run and make better decisions than the companies that make decisions based on bankers. So I think there's a little bit of a dichotomy there in terms of what. So if we had followed Goldman's advice, we'd have destroyed all the value in the company, because 2014, the prices crashed from $90 to $40. And so it's very much a matter of who makes the decisions in the company. But going back to Buddy's original question.
What was the original question? I forgot.
Sorry, I get sidetracked.
So going back to Buddy's original question, how do you improve the EUR? Right? What are the key factors improving EUR? I think in my mind, there's two. One is having an effective frac design that actually provides you uniform coverage of the reservoir. But you don't have dominant fracs propagating. If you have 8 clusters or 15 clusters, you don't have 1 or 2 fracs just going all the way through and just draining a part of the reservoir. That is absolutely key. And part of that is the topic of a lot of discussion at the workshop here, which is how many clusters do you have? How many, how do you pump your fracs, and what kind of proppant do you use, and stuff like that. So there's a huge number of papers that are at this conference and have been for the last, first papers we published on this was almost 8-9 years ago, right? So that's been a big focus of how do you get more uniform drainage of the reservoir. The second part of this, which again, we had a good session this morning, is on refracs. How do you do effective refracking to improve your EURs? The example that was given this morning by the Devon folks was going from a 17% EUR. I don't know if any of you were at the session, but 17% EUR to like 25% is, I think, what she said. Now, those were traditional, that was low-hanging fruit, because it was gel fracs, but done back 15 years ago, and they were refracking this with modern slick water designs. But that slick water design makes a huge difference to your EUR, right? And over the last 15 years, we've learned a lot. So good, effective coverage of the reservoir is number one with the fracs that you do. Two is if you don't have good coverage to begin with, doing refracs that are much more effective. And of course, number three, which I think is coming down the pipe, is EOR. So either gas injection, huff and puff, or whatever this technique is appropriate for your reservoir. I think those three things are the best ways that you can improve your EUR in a given reservoir.
I'll add timing to that too, because when you
Good
bring
point.
wells online, one of the questions that we're always asking ourselves when we're moving the rig to the next pad is how many wells do we want to drill right now? Like, because you're up against like, how many do I have to drill that are obligatory wells versus, maybe that's in the best interest of kind of flip the asset and sell versus how many wells should we drill? Like, what's the optimal spacing for this particular reservoir? How many should I drill and complete now? And then the timing of actually pump in the most effective frac. And then to add one more comment to what you said earlier was I think effective teams too are a big component, because you can have one really smart person on the team, maybe they're reservoir, but if you're lacking on the completion side or the facility side, like you're struggling. So, learning to work together. And I guess during COVID, that's hard when people were working remote if you weren't already having an established team. But I think everything we've kind of touched on across the table has all been great points.
Well, speaking of team, I would suggest one additional aspect of the team is make sure you have at least one Texas Tech graduate. That would help a lot. But anyway, it's just my opinion.
Hey, buddy, before you leave that topic, I guess I'm just curious, and I agree 100% with what all of you said, Mukul, especially the ability to place our frac jobs uniformly across the lateral is a major challenge. Obviously, lithology, geomechanical issues play a part of that. But I guess one other concern I'd like to get thought of there is we're spending a lot of time, stream limited entry has become very popular, and having a good portion of my career being in the conventional world, one of the biggest concerns I have, and I know the topic of this is the rock connection with the fracture, but also I think we don't want to lose sight of the connection back to the wellbore. And I'm really a little concerned that the push for extreme limited entry is in effect reducing those conduits back into the wellbore. So if you've got scaling or any problem with that, is that something we should be worried about?
Well, in my opinion, the benefits of extreme limited entry outweigh some of the risks. So I would say that extreme limited entry is the way to go, because it does remedy a lot of the things, geologic variability, geomechanical variability, all that stuff is something that you have to fight against, and extreme limited entry really helps you in that. So I would say the pros outweigh the cons on that.
I would agree. And can you be more precise about extreme limit entry, how many holes, or define what you mean by extreme limited entry?
I mean, I guess where I'm really concerned is when, we do a lot of projects where we've got one hole clusters.
Yes.
And
Yeah.
That just scares
me.
Yeah. And what would your cluster spacing be?
I mean, it could be down 8 foot, 10 foot, very tight clusters, and they might have 15 or 20 or 30 clusters. But I still just get concerned anytime I'm banking on one perf to stay open and be from a production standpoint. But I agree. I don't disagree with you.
Yeah.
Extreme limited entry, as far as what we've seen in terms of uniform proppant placement, it is the best option there.
And when you think about it, when you have a high delta P going in with extreme limited entry perforating, you may also have a high delta P coming out, and thus scale buildup, where you have a big pressure drop there. So kind of have to have a balance between an effective frac and an effective producing interval at the same time. So,
And I wonder if the other part of this is maybe we just need to keep that in mind from a remedial standpoint on down the line. Maybe simple acid flushes or something to help clean up scale might have a bigger benefit on down the line than we're seeing in a traditional 6 shots per 6 shot drill.
you remember the old Cotton Valley wells?
Oh, yeah.
They'd scale up with salt. You have to go back in and pump water into those wells to get rid of the salt, build up scale. There's a good example.
Well, and I'll say that's kind of one of the reasons to kind of really bring in that integration and taking that with extreme limit entry or any other technology you're applying, is to make sure that those diagnostics and that integration and that bringing that team together, it is happening to look at that and seeing how is this, because I think, it's not, okay, I think this is gonna be better, let's take it forward, let's keep going, let's keep taking those steps that may or may not be good decisions, but actually looking at and evaluating the decisions as you go and making sure you have the data and you're scientifically designing your experiments to take that data and learn from it and grow from it. And so, and this kind of gets back to that you have to integrate it together and plan to learn and ask yourself the question of, is this better for the reservoir at every instant? Instead of saying, okay, well, we've learned, now let's keep just pulling that forward and trying harder and harder on that. Instead of every time taking the time and saying, okay, is this still better for the reservoir? And people make those decisions. And I think Colin really mentioned it before, is people don't want to go back. And I've seen this in the conventional side and the unconventional side as well. Say, this is the way we do it because this is the way we do it. And that mistake can lead to very huge problems, can lead to drilling problems, can lead to complete inability to do your diagnostics, whatever that might be later, whether even if that's just logs, can just ruin everything going forward if you don't say, okay, but how does this affect everything else? And that's where you really lose that EUR performance.
Yes.
So I've been thinking, what rate does it take to have an effective practice? So I'm just thinking rate per cluster. You haven't, sort of a number in your mind of what rate would you need per cluster to have an effective practice?
I usually think of it in terms of rate per perforation rather than rate per cluster. And so being north of 2 barrels a minute per perf is required, preferably more, 2.5 maybe, or 3, just to give you extreme limited entry.
So whether you have 1 perf, or 2 perf, or 3 or 4, you want.
Well, yeah, I mean, hopefully you don't have one or that few, but that's how I think of it, because that's what controls the delta P across the perforation. So it's more the rate per perforation rather than anything else in my mind.
What do you think, Tanner?
Yeah,
How are we
so
going to optimize these designs?
we see vast ranges. 2 is kind of always what it had been for the last X amount of years. More recently, I mean, we see 4 to 6. Again, going barrels per perf, we see more 4 to 6 ranges.
I'll just make one comment on the scale question. A lot of people in the industry don't recognize this, but the formation of salt that you were talking about, buddy, that happens much more in gas wells than it does in oil wells.
Cotton Valley example. Yeah.
And the reason is very simple. And I'm going to be a professor here again, but Raoult's law. None of you remember this, I'm sure, from thermodynamics, but Raoult's law basically says the mole fraction of water in the gas phase is the vapor pressure divided by the pressure, right, in gases. So as the gas pressure drops, the mole fraction of water in the gas increases. And so it dries out the formation. And we have written a series of papers on this, 2 or 3 papers on this, but that's why gas wells dry out, because of Raoult's law. So thermodynamics is useful.
No, we don't use that stuff anymore, for crying out loud. That was a school.
But that's what happens in gas well, and that's why gas wells dry out and not oil wells.
Yes.
To follow up on all this, I'm actually huge, fan of stream limit entry, and I'm more on the 5, 6, 7 barrels per minute.
Okay.
So yeah, I guess a lot of the folks have said that. I personally haven't seen a decrease. Actually, we've seen an increase in EURs. And I think a lot of it is exactly what you just summarized. It is probably with increased perf efficiencies. Thus, you see higher EURs over time, a more steady decline. I guess the question, since I'm on the other side, is as a professor, and you see a lot of projects all across basins, different basins, do you see any examples in specific basins where you actually choke in the reservoir?
I personally have not seen that. But over long term, in gas wells, you can, if you have high salinity brines, and then there's a possibility of restriction induced by the drying out of the reservoir as a result of salt precipitation in and around the perfs and so on. And Buddy's right, in some of the more conventional, quote unquote, conventional reservoirs, you do see, if you do a freshwater flush, you will actually see an increase in production, primarily because you've dissolved some of the salts and you get back some production. So that has been observed 20 years ago.
Actually, I had an example of the wells that I worked on in the Mid-Con, pretty near kind of Woodroof, people going back over there, where we saw that specifically. We never saw the eyepiece I mean, IPs were maybe a fraction, probably half of what we expected.
Yeah.
Long term, 180 to 60 days later, cumes way over exceeded our expectations, and a lot of it was this is not a specifically dry gas. This is more of a wet gas, high NGL area where it may exceed 120 barrels per annum. So we ended up actually cuming a lot more liquids just by the simple design of potentially kind of limiting of how much gas is coming through at the reservoir, from the reservoir.
Okay, we always like to end our ProTech talks with some just common sense advice from our panelists. So I'm going to start with you, Dena. It's probably not fair. Probably weren't expecting this, but it wasn't on the list of questions I sent you. So my question to you is, what do you, as a professional, what do you think was the biggest mistake you made in your career?
Biggest mistake I made?
Yeah, you could go back.
Thinking that, or I told you, I don't
If
know.
you could go back and repeat something that you did or do it better, what would it be?
I told you I picked engineering because it required the least amount of English in school, but it turns out it's probably one of the most important parts of our jobs, especially if you work in operations today. I mean, I had to take 2 English classes and I was just thankful to get through them. I hated English so much. I'm a math and science person, but I mean, writing, like putting out procedures or sending emails, even just making sure that what you think you're saying is being effectively communicated. And I'll take it to the academic, because I think you guys had mentioned kind of tying that together. And then I would also say like degrees don't always outrank experience. You know, you work with guys in the field that have 30+ years experience. And just because you come out of school, you know, with your degree in engineering or PhD or, you know, done all this kind of research and know everything, you know, sometimes you need to listen to what your field guys are saying. They may not have a degree, but I've actually seen where, you know, they will do exactly what you say, even if they know it's wrong, if you don't take time to listen and hear, you know, really listen to people and at least hear them out.
Good advice. Yeah. How about it? Tanner, what's the biggest mistake you made? Trinity University or since?
I'd say taking a job in North Dakota in the dead of winter.
Okay. That probably wasn't a good idea, no.
We took a Texas frac crew that never fracked in sub-zero to North Dakota. And I think we got through about 60 stages in 2 months. So
2 months.
that's not very fun.
Good old Minot, huh?
Yeah, Watford City.
Why not Minot? Colin, what was the biggest mistake you've made along the way you think that you'd like to repeat differently?
Oh, yeah. There's too many to count. I think Dena's point about listening to field people, just like our own pride gets in the way. And I think it's more a mindset, like maybe it's like I opine on this, but like more of a mindset I've had at different points in my career where I think that I'm the smartest guy in the room, or I think that I'm right, or I think, you know, just because I, you know, have an engineering degree, I know more or whatever, and that's never true. And I think that the biggest aspects that have hurt projects has been my pride.
Pride goes before a stumble, as a good book says. Okay, one last question, and it's kind of related. And I think Dena's already answered it on her side. What do you wish you knew more about before you began your career? She wished you knew better English. Okay. What do you wish you knew more about when you started your career? I'm the smartest man in the room.
That's not true,
There has to be something.
but I'm just thinking about what I wish I, you know, sometimes when you start your career, you work on problems, and this happens a lot. You work on problems that you know the most about, and so when I started my career, worked on petrophysics, and because I knew a lot about that. It turns out that actually is important, but it's not the most important thing. So I always tell people that hammers and nails. And so a lot of people in their careers will carry the same hammer, regardless or whether there's good nails to be hammered down or not. And so my advice to people always is look for the most important nails and find the right hammer to nail down that particular nail. Because if you keep the same hammer in your hand throughout your career, you're going to be hammering down nails that nobody cares about. So
You have to do a paper on that. You know, that'd be a good topic.
Well, I'll throw out one. We've asked this question in a number of ProTechTalks, and one of the things that upper level managers have said, they wish their people that they hired knew more about business acumen. You know, understand profit loss. You know, so they understand why the corporation does what they do. You know, and if you can't make a profit, you can't keep going. So business acumen would be one. What do you wish you knew more about?
So, I mean, and obviously coming from a chemical engineering background, I knew very little about the industry coming in. So there's a lot of that I would have liked to know. But I think more than that, just kind of understanding and kind of seeing that, you know, that things tie together and knowing that I need to start looking at how that ties together early on, especially, you know, and saying, okay, now I'm learning all this stuff. You know, I started out learning fracturing, and okay, well, why does this matter for everything else, and not just let's just get this job away, which is kind of your basic frac engineer. That's the goal, is to get this thing in the ground, and not really understanding that it drives a lot of other things. And so kind of just, and I think in every point of my career, and whether that's technically minded things or business minded things, it's the knowledge that you have to kind of pull back and say, how does this affect everything else that's going on? You know, how does this decision to change this price on something going to affect everything else that's going on there? Or how does, okay, if I'm going to be talking about, let's do this for this well and this for this reservoir, am I, you know, messing up something else that's going on, or messing up some other kind of diagnostic that I'm doing it? So just kind of knowing that knowledge of, yeah, I have to think about the big picture, think about and knowing and just being able to kind of pull that in and understand that it's not just my little pocket, that everything really matters quite a bit to things.
Colin, what do you wish you knew more about when you got started?
I think the lesson over the last couple of years, I wish I would have known a long time ago, is working with high integrity people is the most important decision you can ever make. And I think, especially when you're trying to build out a team, I think Dena talked about that. You got to make it up of high integrity people. If you don't have high integrity people, it's just, you're going to be running around in circles. And it kind of goes to the finance side and everything else. You want to work with high integrity people. If you work with high integrity people, then you can get somewhere. If you don't, then it's going to be hard.
Okay, Tanner, as a geologist, what do you wish you knew more about?
I always go back to what you just said, for your point there, buddy, the business side, the financial side of it, and that's something that didn't have a ton of exposure when you're out there dropping acid and lifting rocks in college. So
There you go. I agree. Any last questions from the audience?
You would have noticed that Buddy never introduced himself in the beginning. So now he's going to introduce himself.
Oh,
I'm Buddy Woodroof. I'm the technical manager for ProTechnics. I started in the service side. I was in R&D for a number of years developing stimulation cementing products. So that's my background.
And he is the best organizer of these sorts of panels that I know. And he and I were in San Antonio doing a panel like this. Remember
Oh,
this?
yes, how can I forget that one?
This is many years ago. This was an SPE event, and the door bursts open, and about 20 ladies march in front of the audience. They were like 100 of us, 150 of us sitting there. Were you there?
I was there.
Oh, were you really?
Yeah.
Oh gosh. And they have their cell phones in their hands, and they're shouting, literally shouting, "Have you called your mother today? Have you called your mother today?" And they line up in the front, and they keep shouting this. Things like,
He and I are
What?
sitting at the table.
you're sitting at the
each
podium
other.
looking at each other saying, "What the hell is
What
going on?"
happened here? Where did we go wrong?
So these were protesters protesting against fracking. So
Yeah, we're polluting the environment.
we completely took us by
Fossil
surprise.
fuels, you know. And so one of the participants there, as they were slipping, and we were very respectful, we didn't boo them out or anything, we
No.
listened, they spoke their piece and they left, and you could hear one gentleman whispering under his breath, "How did you ladies get here today? Did you ride a bicycle?" Well, thank you very much
Thank
for
you.
joining us, and have a great rest of the conference. And thank you for panelists for spending the time with us. It's been very informative.
Thank you.